Hello all. So till now we were studying different topics about work done, the potential difference, and other topics also. We also studied the potential gradient also. So before going to next topic, we will see some problems on these topics. So first we will see problems on in this video. We will see problems on the work done. Then we will go on the problems on potential and potential difference. Then later we will go for problems on potential gradient. So first problem I'll solve here is the problems on work done. So the given problem is an electrostatic field is given by E is equal to minus 8xy ax cap minus 4x square ay cap plus az cap volt per meter. The charge of 6 coulomb is to be moved from B 1, 8, 5 to A 2, 18, 6. Find the work done in each of the following cases. First case is the path of the movement of the charge is given y is equal to 3x square plus z and z is equal to x plus 4. And second case they given the path of movement is straight line from B to A. So next they given in the question, show that work done remains same and is independent of path selected. So we have to find what is the work done in first case when path is this one, and in second case when path is straight line from B to A. So given is here the electric field intensity is given E is equal to minus 8xy ax cap minus 4x square ay cap plus az cap is the electric field intensity, and the charge is given is 6 coulomb, and we have to move a charge from 6 coulomb of charge from point B to point A. So we have to move charge of 6 coulomb from point B to point A. So as you know, the equation for work done is given by W is equal to minus Q integration of B to A E dot dl. So the work done equation is this one. Now, so you know Q, you know the points from B to A, what is the limits for from point B to A, and you know E. And what is the dl here? So it is in which coordinate system? They given in Cartesian coordinate system, because x, y, z is there, so it is a Cartesian coordinate system. The differential length in Cartesian coordinate system is given by dl vector, which is equal to dx into ax cap plus dy into ay cap plus dz into az cap. Now if you take dot product between E dot dl, so E dot dl, so we know E is equal to minus 8xy ax cap minus 4x square ay cap plus az cap dot dl is dx into ax cap plus dy into ay cap plus dz into az cap. Now if you take dot product, so ax dot x will be 1, ax dot ay will be 0, similarly ax dot az will be 0. Similarly ay dot ay is 1, ay dot other component is 0. Similarly az dot az will be 1, az dot other component will be 0. So simplifying this, you will get minus 8xy dx minus 4x square dy plus dz. So E dot dl you will get. Now, so substituting this in this equation, so you will get W is equal to minus Q, the integration from B to A, 8xy dx minus 4x square dy plus dz. So subtracting this integration, so you will get this one. So here limit for B to A, so here we are integrating with respect to dx. So first limit is with respect to x. So here we are integrating with respect to y. So limit should be with respect to y. And here we are integrating with respect to z. So limit should be with respect to z. But one thing you can note here, in first term, there is a term depending on y also, because there is a y term. In second term, there is a term depends on x term. But it is an integration with respect to x and integration with respect to y. So we will convert this y term in terms of x. Similarly, this dy we are converting the differentiation with respect to x. So how we can convert is, so we know that in this equation the y is given, y is equal to 3x square plus z, and they also given z is equal to x plus 4. Using these two equations we will convert the y terms into x terms, because we want to integrate with respect to only, if there is only one term, one variable, then we can integrate easily. Otherwise it will be, the term will be remains there, so you can't integrate. So that's why we are converting x y terms into x terms. So you know that y is equal to 3x square plus z, z is equal to x plus 4. Now I will substitute this z in above equation. So you will get y is equal to, in the place of z, x plus 4 I will put, so y is equal to 3x plus x square plus x plus 4. So I got y is as this equation. Now I want to find dy in terms of dx. So I will differentiate this equation, y is equal to 3x square plus x plus 4 with respect to x. Then I will get dy which is equal to 6 plus 1 into dx. So if you integrate this equation, y 3x square, y is equal to 3x square plus x plus 4 with respect to x, then you will get dy which is equal to, the differentiation of 3x square with respect to x is 6x, plus differentiation of x with respect to x is 1, plus differentiation of 4 with respect to x is 0. So you will get 6x plus 1 into dx. Now you have all the three terms here. So I will substitute limits for this. What is the limit for x with respect to x? If you see the coordinates of a and b, here x with, in b x coordinates is 1 and in a x coordinates is 2. So the limit will vary from 1 to 2. Similarly, if you see y coordinates, in b it is 8 and in a it is 18. So y coordinate, y limits will be 8 to 18. Similarly, z is from 5 to 6. Now in this equation I will substitute what is y in terms of x. So what is y in terms of x? So I can substitute, in the place of y I can substitute 3x square plus x plus 4. So it will be 8x into 3x square plus x plus 4 into dx. Now in the place of dy here I will substitute 6x plus 1 into dx. So 6 plus x plus 1 into dx. But what should be the limit now? Previously it was the limit corresponding to y. Now I have to change the limits to corresponding to x. So limit corresponding to x is 1 to 2. So after substituting all the things, I will get equation as minus q into x limit is 1 to 2 minus 8x into 3x square plus x plus 4 into dx, minus the limit for x again is 1 to 2 4x square into 6x plus 1 into dx, plus z limit is 5 to 6 dz. So if you integrate this, you will simplify and integrate this, you will get minus q into minus 256 plus 1. So the final answer will be 1530 joules. So it is 1530 joules you need to be work done to move a charge, 6 coulomb of charge from point B to point A when path is y is equal to 3x square plus z and z is equal to x plus 4. So if you, now this is the case 1. So case 2, the given is, in case 2 it is the path is straight line path from B to A. A straight line path from B to A. Now we have to obtain what is the straight line equation for from path B to A. For that I'll write the three plane equation. What are the three different planes in Cartesian coordinate system? One is xy plane, other one is xz plane, and last one is yz plane. So first I will take xy plane. So it can be written as y minus yb, which is equal to ya minus yb divided by xa minus xb into x minus xb. And one more equation for yz plane is z minus zb is equal to za minus zb divided by ya minus yb into y minus yb. Similarly for xz plane, this is the equation. So to obtain equation for straight line, I can consider the equation of any two planes. So here I am considering first two equations to solve this problem. So substituting what is YB is 8 and YAS 18 and XAS 2 and XB as 1. So I will get equation as y is equal to 10x minus 2. So substituting coordinates of a and b with respect to x and y. So you will get equation for y as 10x minus 2. Similarly, to obtain the dy, so I will write 10. If you differentiate with respect to this equation with respect to x, you will get dy is equal to 10 into dx. Similarly, if you substitute z and y in the second equation, you will get so 10z which is equal to y plus 42. Now using this y is equal to 10x minus 2 and dy is equal to 10 dx, I can obtain what is the work done to move this charge. Now this is the integrating equation. So as we see in the previous case, same equation, w is equal to minus q x 1 to 2 8xy dx minus y 8 to 18 4x square dy plus z 5 to 6 dz. Now in the place of y and dy, I have to substitute y is equal to 10x minus 2 and dy is equal to 10 dx. So substituting here, you will get in the place of y, I have substituted 10x minus 2 and in the place of dy, I have substituted 10 dx. So but limit for second one will change from y limit to x limit. So x limit is from 1 to 2. So simplifying this and integrating this, you will get the minus 250y into minus 6, you will get 1530 joules. If you compare both answers, for first case also you got 1530 joules and second case also you got 1530 joules. Now, so if you observe both the cases, irrespective of the paths, if it is straight line or whatever the path of the movement of the charge from one place to other place, the work done will remain same, right? So if you observe both the results of the work done, the whatever the path given, the work done to move a charge from point B to point A, work done remains same. It is 1530 joules. So in next videos, we will see two more problems on work done. Then we will move on to problem on the potential difference and potentials. Thank you.